Hi, welcome to JCON. It's great that you're all here to our first keynote, even though we're experiencing some minor technical difficulties, but let's move on from that. My name is Richard. On behalf of the whole JCON team and our sponsors, I would like to thank you for joining JCON today. We appreciate your attendance and hope you will have fun and learn something new. We've got an exciting agenda for you, and our content board had to choose from over 300 submitted sessions, and we only had about 150 slots. So thank you for everyone that made that selection and dug through all of those proposals. Today and tomorrow and on the following days, you can see over 116 speakers, roughly 150 presentations, and we have 2,600 attendees from over 70 countries here. This is totally great. We have the whole world here, 6 continents. So this is fun to do, and it's amazing that you're all here and joined us. I'd like to thank our sponsors that make JCON possible, so we can give away tickets for our Java user groups that support the conference. So please make sure to visit their websites, check out their products, and see what they have to offer. I'm very happy that we can announce that we will have JCON in person next year in June. The dates are already fixed. It will be from the 20th of June to the 23rd of June, and it will be in Germany. We are locating the best location for you so we can have a lot of fun, see some interesting topics. And also for all those that cannot come to Germany and join JCON in person, there will be a JCON online in the fall, in November of 2023. So we're happy that everything is about everything that's going on. That's really great. And I have one more request. Could you please have a look at our session planner? We have a feedback section there. And we always get the feedback that it's really helpful for the speakers and also for us, the organizers, if you give us feedback. And if you click the little smiley faces, please add one sentence, a one-liner, or maybe 2 sentences, and give us some feedback on the session. Just clicking the smileys does not do the job for us. It's just a rough indicator, but please give a little and write a sentence or 2. With that said, and no further ado, I'd like to welcome Adam. Thank you, Adam, for being here. You're a JCON regular, and it's always fun to have talks with you. And unfortunately, today I don't have bear woods for you, but you have brought something very unusual. You brought us slides. So what's wrong with you? You're still muted, Adam. And still muted. Okay, he's not hearing me, right?
So, yeah, sure. This is, I'm beginner speaker, so unmuting is very important. So, what I noticed is that you told me once that you have no time to code anymore. So, I try to be inclusive and created some slides, for the organizers.
Oh, that's very considerate of you. Thank you. Just for me.
And you also gave me the bear woods, which is a German kind of vodka or liquor. And after bear woods, it's impossible to code. I can manage the slides, but I cannot manage the code anymore.
Yeah, I shouldn't have drank it all at once. So, okay.
Oh, okay. This next time you have to tell me this, because.
Okay.
Yeah.
I will. Okay, go ahead, Adam. Feel free. And we will.
I will steal your desktop first.
Yes, please.
It's mine. And to attendees, write questions to the chat. Also, this is a keynote and lots of slides. I really like questions, and we can have more fun with questions. It doesn't have to be a usual boring keynote. I don't like keynotes usually, so let's have some fun. And if there is no questions, Richard has to ask the questions. So either you ask or you don't ask. I will get the questions anyway. So some slides. Okay, so there are some workshops around the corner in December about serverless Java, but more importantly, there's a podcast, and I had a star guest called Marcus Cat, and what we discuss on the podcast is the microstream ideas. It's also interesting to you. So if you like, listen to the podcast, and you will find out the background about microstream and even what Marcus did, as he was 5. So also interesting. And if there are any questions left and you I mean, you say, the Keynote is very serious thing, and you can always ask questions here. So why Java? So after all these years, I still do Java, and actually the last 2 years or 3 years, even more than before, and not enough. I actually migrated lots of scripting stuff to Java, which is unusual these days. But the first thing, which is crucial, is execution speed. Why? Because the first time in history in the cloud, you actually pay in serverless world for gigabyte seconds, and Java is incredibly fast. So you can actually save lots of 10-20% of cache using just Java, which is already good. And why that? Because, all right, Java runs on JVM, and the often it's invoked, the faster it gets. Of course, you could use your low-level programming to achieve the same if you exactly know what you are doing. But with Java, you can write simple code, and it is fast enough. I think Java is productive if you are reasonable. But if you start, with 20 layers and, I don't know, factories and the reflection, it is no more productive. But if you are reasonable and write simple code, I would say Java is great. Is established. I mean, nearly everyone knows Java. Comes with great tooling. I would say, the tooling improved for other languages, but I would say in Java is still stellar. So right now I'm using Visual Studio Code a lot, and this is remarkable how good it is. I will use NetBeans once again. I just need time, to switch to it. But I use IntelliJ from time to time, and I use a lot Eclipse, and all the tools were actually great. I have to say, there's not like this is like personal preference what to choose. And the last one is really important, because I will show you towards the end of the session. So whatever you see is relevant. So it's not like, I try to make Java popular. It's very relevant to serverless Java. So excellent build tools. What I use actually only is Maven. And what Maven is able to do is not only build your stuff, but deploy your stuff. So there's Maven deploy, and create, something reusable, which I will refer later with CDK. So these are the ideas. And again, you should every slide at least one question, right? So now, Richard, do you have a question? You like the formatting of the slide? Very good.
Perfect. And you already mentioned Maven, so I'm happy already. So that's good. So
why?
No
are you sponsored by Maven, right? So
no, we're not.
Okay. Now, why slides? Because stuff like that. So I thought, how to tell you the road to serverless, because there are other factors which are important. So 1995, as I started with Java, there was infrastructure as whatever works, I would say. How this worked is our goal was to build one of my first project was CMS, content management system in Java, JDK 1.0. And the COO asked us what we need. We say, okay, server, which one? We say, okay, no idea. Sun would be great. It's like, okay, too expensive. And then HP, we got HP, so like a cube, and no one had idea what to do. So we tried to install the software, and then we got Java on the machine. So this was 1995. So in 2000, we were told in larger projects, developers are no more, responsible for production and operations. So they say, there's another department which runs the server. You only have to copy the ER over and everything will work. And I would say this was serverless. Since then, for me, I said, okay, if this is the case, I don't care about, the servers anymore. I just focus on business logic, copy it over, and this is your job, to do it. It worked somehow good. So there was actually a nice thing what I remember. It was around 2003. There was a huge WebSphere in south of Germany. And the people who run WebSphere had no idea about Java. They didn't know class path. So I try to now dictate them what to do to set up the application, and I say minus class path, and we had to put everything, in the jars. JDBC, for instance, had to be there in the class path, and they didn't know class path, so they forgot the blank, minus class path blank, and then the path. The result was everything crashed, and they say now it's running. So I tried to run the test, nothing runs. So I spent 3 hours on the phone just to find out that we need a blank after class path. So this was like the experience, the point number 2. 2010, especially with Netflix, I would say this is how it started. You build it, you run it. So actually in 2010, it was identical than 1995. You say, okay, you are responsible for the entire thing, maybe not for the hardware, but if you build the software, you should also running, which meant you should be responsible for logs, for monitoring, for observability, which actually we did 1995 because there was no one to help us. So we had to build software, and we should be able to find out what's going wrong in production. And I would say in 2018, roughly, serverless was a little bit bigger than before, and serverless was combined with infrastructure as code. Before that, I completely ignored the entire serverless because it was incredible. So in order to create the functions, you had to spend, there were even external tools to help us with the entire stuff. So, okay, forget it. But 2018, we got infrastructure as code and serverless, and 2020 maybe. I heard the term the first time, self-provisioned runtimes, which actually we do all the time, but I didn't knew that this is the thing. What it means is we have a Java app, and inside a Java app, there is an infrastructure code which automatically provisions the entire thing. So actually, it is exactly the opposite to 1995, because in 1995, we had the server first, and then we install the software, and into 2020, everything installs by itself, but we need the cloud, right? But the principle was identical. Again, any questions? No questions. So what's wrong with you? This is the unique keynote where you can actually ask questions. So for no questions, even better. Now about architectures. So very fast is also very relevant to serverless, because how it started with applets. And what I remember is what you tried to do at the beginning, maybe Richard as well. So we tried to connect from applet to the backend. And I tried, to use JDBC, but it was not available. There was JDBC ODBC bridge. And actually prior to that, we had to use the native Oracle ODB2 driver. So the JDBC came later, but before you had to use the real Oracle connection to connect, to the thing. So what it meant is the applets, our applet had a direct connection to a database, which is crazy right now, but this is how work, the first ideas. And then we say, okay, there's a little bit too insecure because we have to store the passwords there. And so the next idea would be this is the use the same architecture with remote method invocation, RMI, so like a small middleware. But the interesting part is that back then the JDBC connections per applet had exactly the same challenges what we have right now with Lambdas. Like we have one Java application with a connection to database. So the question is now, what we should do? Is every Lambda has a connection pool or single connection? What to do? Exactly the same problems we had, 20 years ago. And this is why there was the subtitle in my keynote, which I forgot to mention, was, solving solved problems, because everything repeats with different names. So servlets got connection pooling. And I remember, so this was also 1998. We killed with Java everything, because with connection pooling, you could pay less, or you paid less for Oracle databases. This was the cool thing, because you had to pay per connection. And with Java, we could set up, 10, 15 connections, and we only had to pay 10, 50 licenses and not, hundreds of licenses, which was a really big deal. I guess actually lots of the project because of the fact. So what it means is the connection pooling not only reduced the costs, it also increased the scalability. If we go serverless Java to the cloud, we have the same problem. In one point of time, we need a solution for connection pooling or something different, because we cannot just have thousands of connections. So costs are not the factor. The factor is memory and scalability. That's the problem. So in one point of time, we got EJBs or similar technology. What meant is in the backend, we got JPA with JDBC with connection pooling again. And to give you an idea, in most projects, we had roughly 30, 35 connections, and we can serve thousands of clients. So there was a there is an multiple ends to M relation. So then Eclipse RCP was huge, JavaFX and Swing, and there were two modes. We were in successful project with domain-driven design, which is very similar to the serverless mode. With what it meant is we built basically fat client, but the term fat client was forbidden. So I always used the term rich client, which was absolutely okay. So we never mentioned fat client, but we built rich clients. What it meant is we had an JPA with entity manager with open session, and we used attached JPA entities to the UI. And the cool story is it was highly object oriented and very productive system, because the users could modify the objects and then put save, and the save just started a new transactions and started and ended a new transactions, committed the transaction, and then all the diffs were written to a database. So the diffs were handled by by JPA or by Hibernate. So it started with Hibernate and then we migrated to JPA. So exactly here in one company, they say it doesn't scale. So we delivered, 300 desktops. So we had 300 connections to database back then. The same architecture with service oriented. SOA was huge. So we say, okay, the client is a thin client with Eclipse RCP. So it's called via Corba or SOAP. It depended, on projects to the backend. So we get a JDBC connection pooling again. So then we go JSF, Vardin, Google Web Toolkit, and this was also very similar architecture. With Vardin, you could even do the trick with the JPA if Vardin was stateful, because you could inject to Vardin the entity manager and keep, all the objects open. But what you see already, some solutions can use connection pooling, others cannot. So this is the interesting part, what we learned over the years in Java. And what still remained, a connection is memory for the resource. So we cannot just open hundreds of thousands of connections. This is what we learned over the years. Any questions? Rihad, what's wrong with you?
There are no questions about this slide, but people keep asking why you prefer Maven over Gradle. So if you want to start a war now, or do you want to wait until the end of the session?
Because, okay, what I tried, I didn't introduce myself. So I spent lots of time with Java and microprofile. So usually my Maven looked like one dependency and no plugins. So I could use Gradle, but there would be no difference. Actually, I did back then even some screencasts, Gradle versus Maven in my world, no difference. And Maven was first, I guess. And this is why I stick with Maven. But I could use Gradle. I don't care. But there should be reason to use Gradle in my world. So that's the only thing. Maven is good enough. And in my project is even faster. So that's all. And this is also the reason why I use JVM, so Java as a language, and not, Scala, Groovy, or whatever, because Java was first. It's good enough for me. It's getting better. Java 19 is around the corner, which I'm really looking forward. So this is the same answer. So nothing, sophisticated. So if you like to use Gradle, use Gradle. So no problem. So now the why clouds first. If you don't have any problems, don't use clouds. This is my advice. It's exactly the same. If you don't have any problems, don't use microservices. Just create a monolith. So usually, if you behave the same on premise and in the clouds are more expensive. So if you go to the clouds, in my opinion, you have to add a significant added value. Otherwise, it is pointless. So it's not like you migrate your system, lift and shift to the cloud and everything is getting better. In my opinion, everything gets worse. But what are the reasons in the last 3 years I was forced to go to clouds? So interestingly, the first one was not scalability. So on-premise was also always fast enough, rather than disaster recovery. DR is disaster recovery. So in the last 3 years, the companies expanded and there was a challenge to find another data center which is close enough to have highly available system. And then we are forced to go to clouds. This is one of my projects. The other project was security, encryption, certificate rotation and automation. In my current projects, I don't think we could provide on-premise the same level of security on paper, because clouds are certified in any possible way. And so that's the reason. So we have to be secure on paper. I mean, I cannot just review the entire stack and say this is secure, this is not secure. So from political and paper reasons, clouds are actually very secure. So if you search for certifications, you will find everything and compliance in the clouds. The third point is automation, which is, I would say, this is one of the benefits of the clouds, not the reason to go to the clouds, but automation, what it means is we are able to provision everything, without clicking. And now this is more interesting for me. Shared responsibility model. This is what I like, because I don't like to care about the low-level stuff anymore, because it usually causes trouble, Docker super images, or forgotten libraries, or stuff which you have to care about, unpatched operating systems. So if I have to care about this, there has to be a significant added value, like significantly lower costs or something like this. Undifferentiated heavy lifting. This is actually a term, I don't know whether it's from AWS, but I think AWS uses it a lot, this undifferentiated heavy lifting. I don't think this was invented by AWS. What it actually means is my clients lost interest in hardware and low-level plumbing. And the last one is a big one, cost transparency. So if you compare, you know, a on-premise, you know, solution like Kubernetes or even cloud Kubernetes with a serverless solution. The big difference is if you have a not serverless solution, what usually happens, it runs all the time and you pay the bill all the time. If you have a serverless solution, what it usually means, you pay per API. So at the end of the month, you can go to management and say, look, this use case was executed 100 times and is more expensive than the other one. So this is the justification. But if you have a Kubernetes cluster in cloud, no one knows what's inside. So you can provide your billing, but you have to implement the billing. So there was the first, you know, already now I have to get, you know, 100 heretical comments because I said something negative about Kubernetes, which is usually on conferences, you know, it's
we don't
chat
have
overloading.
We have no chat overloading with Kubernetes, but there's one question in the chat. What about the cloud? If you are hacked, then suddenly everything might be gone instantly because you are not permitted to access internet anymore.
If I'm not permitted to access internet anymore, it doesn't matter because usually I also not sit in the data center. So I have to say I'm an external developer. I have to access the data centers for my clients in the cloud in the same way. So if I'm hacked, I also cannot access the data center for my clients. I would say there's not a huge differentiation factor. If the clouds get hacked, this is the interesting part, I would say you can survive more in the cloud because what we, for instance, do right now is we have one app per account. So we have multiple AWS accounts, for instance. So if one account gets hacked, the others are not hacked. So you can do more. If you are in on-premise, it really depends on clients, how sophisticated the data center is. And what we also do in the cloud, we encrypt everything. So if someone hacks the cloud, then it gets, you know, a binary blob, nothing happens there. So I would say you have to do something about this. What you cannot do, you cannot just, you know, pick your system from on-premise and push it to the cloud. This would be a disaster. But if you think, you know, if you use the clouds in proper way, then I think it's better than on-premise. But it's not necessarily cheaper. It is better. So, okay, very good question, actually. Kudos to the who asked the question. Very good.
There's another question and another one that lines up very tightly to that one. So the first question is, so is there a trend nowadays for hybrid setups instead of all in cloud setup? And another comment is, if we can't move the entire solution to the cloud at once, do you recommend partial cloud or partial on-premise hybrid solution?
Okay, first, if you migrate to cloud, there should be a reason, a clear strategy why we are doing this. There is no reason I would do nothing. So now my projects, most of my clients have, how to call it, private clouds. So they have direct connect or express route in Asia. So there is a direct connection between on-premise and the cloud, and no one sees what's going on in the cloud. So the cloud looks like extended data center. In the View projects, we have the public IP addresses where we have real public clouds. I would say 80% private, 20% public. This is my ratio right now. Yeah, and recommending is, I would say, I don't believe in lift and shift. Except, there are urgent reasons, like we are running out of servers and we have to go to the cloud. So this is like an absolute hack. So, but this is like lift and shift means keep everything as it is and run, virtual machine or Kubernetes or Docker in the cloud. So I don't believe in it. Okay, very good. Other questions?
There's another really good one. How do you justify the usage of Java when there are other less resource-intensive options like Go, Node.js, and Rust?
Money. Because as I said, in Lambda, Java runs incredibly fast. And what I know, it runs, so this was my measurements, right? Faster than Node.js or faster than Python. So with Rust, this is interesting. And what happens then? Because I actually don't know whether if you run, so I had actually a discussion with a Rust guru, and what turned out that what I do in the cloud, I never use Java SE in the cloud. I always use some Quarkus, and you could use Micronaut for it, but Quarkus or Micronaut in the cloud. And the Rust guys, they don't use, like they don't, how to call it? If they write AWS Lambda, it's not the same. They write everything from scratch. They use the Java SE, but not the framework on top of it. And we had a chat, like he doesn't recommend the frameworks, like I forgot the name, like a web framework which similar to JAX-RS. So I would say what would be interesting is to have, a comparison between microprofile Quarkus and Rust with framework on a Lambda and run it and see what's faster. This would be interesting. And what I can tell you, Java is faster than the scripting language by 10%. What it means is we can save 10% costs. This is clear. So for me, there is no reason to choose something different. And if you're already using scripting languages, you can say, okay, is there a reason to migrate to Java to save 10%, 20% of the cost? So this is actually, I would say, forgot about that. What I usually say in my cloud, sessions, cloud are about costs. All the architectures are cost-based. If you have, endless budget, then we have old architecture, what we do on premise, but you are always constrained by the budget, by the running costs and all my projects. So what we pick, or we profile projects according to costs, not necessary runtime performance. Very good.
Do we have time for one more question about?
Yeah, sure.
What about cold starts of JVM in Lambda? One of your favorite topics, of course.
Yeah, of course. The first start is actually, this is what I wanted to show if there are no questions. The first start with my micro profile, everything is roughly 2 seconds, and you pay for a half seconds, and all subsequent calls are 20, 30 milliseconds with full stack micro profile applications. There's enough, screencasts. I did it in the Java user group in Weiden. We can do it again. So I do it all the time. So I would say Java is incredibly fast. And this is as fast that we don't use GraalVM on AWS because the standard Corretto JVM executes faster if it's warm than GraalVM. We could use to minimize the first startup, but it doesn't matter. Another trick, what you do, we use micro profile health checks, for instance, and then you could use Elastic Load Balancer health checks, or you can use I think it's called CloudWatch Synthetics is the service, which has a kind of a health check. So if it calls the Lambda every 2 minutes, it's always warm and costs you nothing. So this is a trick, right? And to my measurement, so what I saw in Frankfurt, every 170 seconds, the Lambda becomes cold and gets warm again. It really depends on the memory, whatever. So if you have application which gets cold every 2 minutes, it will be never cold. So this is my observation. And by the way, I'm talking about AWS because AWS was first, and I also experimented a lot with Oracle project FN Java, also a great project. It's open source, completely FN Java. So if you're interested in non-AWS things, take a look at FN Java, which is, I think, the base for Oracle Cloud Functions. Okay, now, this is what I'm not interested in. So it's okay, for instance, a cloud provider, Amazon, by the way, the same slide you find on Microsoft Azure, almost the same. So we have here the foundation, and then this is what AWS is responsible for, and we would be responsible for operating system, whatever. So if I see already operating system, I'm no more interested because we have to patch it. For instance, I know what remember if you run Kubernetes in the cloud, you are forced actually to upgrade, which I'm absolutely not interested in, or not interested. This is in the cloud. There should be an improvement in the cloud, what I already mentioned. Cloud should not behave as your on-premise data center. This is my personal opinion. So I'm more interested in it in this slide. So this is more like serverless. So what it means is the cloud does everything. And for instance, if I do AWS Lambda, I don't even have to push, Java to the cloud. I say just Java 11, and it will pick Corretto 11 on the Microsoft Azure will pick the OpenJDK on. So I don't even have to ship Java. So it means the cloud provider is responsible for patching Java. So it's even way better than Docker. Actually, I have to say, in the last year or this year and last year, I never used Docker again. So we have Dockerless deployments because we just ship functions on zip and nothing else. Okay. Pay-as-you-go. This is what I wanted actually to tell you. Cloud-driven architecture, cost-driven architecture. So this is the most important thing. So we actually refactor stuff looking at the invoice and not, on JVisual VM. This is actually what also changed in the last years. The evolution. So this is this slide I showed already multiple times. So as I started with J2E application server, and they believe that the web container, EJB containers are separated, and these shared deployments, which is no more true for 15 years, I would say. So now this is more modern. This is like, for me, mostly Quarkus. Could be Whitefly. One project was to use Whitefly, identical architecture, except there is no micro. Yeah, this is Whitefly instead of Quarkus. One app. And now what we do, the same bytecode, and we replace, the Docker with Lambda. This is the only difference. So there's the same bytecode, the same source code. In my current project, we have several hundreds Java classes running in a Lambda, and it still runs fast because Java optimized really well. On Java plus Quarkus, they are optimizing really, really well. Okay, so now what's the difference? I told you, the same source code, and so why this session, right? Because it's thinking about serverless. So if everything is the same and everything's great, what's the problem? The problem is this: if we have an app server, there's one app server or maybe two in a cluster, and we have threads, and every transaction, every request is a thread. So what it means is on application server, we can have a hash map, which is static, and we can share stuff, or we can pass data back and forth. This is the application server. On functions, it is exactly the same code, but they are not threads. Actually, you could have threads inside, but every transaction is a process which starts and stops. So this is the main difference to application servers. The same source code, but different process model. And I really thought about how to draw it, right? Because this is one of the reasons why I created the slides, because it's impossible to show with code, right? But you can even, what we do here, we, for instance, use inside AWS Lambda parallel stream from JDK, so we can start multiple threads, lots of them, but inside a process, right? So this is the crazy part. So if you know Whitefly or JBoss on Lambda, we have 1,000 parallel transactions. You will get 1,000 independent Whiteflies. This is the crazy part. Okay, this is the main difference between both. Source code is the same. So and now it comes, the advantages of Java. What I observed, the scripting community like Node.js, Python, they are about to write single purpose functions. So they write a lot of functions and they stitch them together. We never did it in Java, because in Java, we have, nice packaging. We have Maven, what I told you. We have nice structure. So we create a big lambdas. So as I said, currently 500 Java classes, very good to maintain because the code is lean and structured and no impact on performance. The cool story is, if the entire app is a Lambda, fed Lambda, you can deploy it, ship it at once, and it's better than on Docker. So this is our strategy, and it works surprisingly well, and developers like it. And other cool story is, if you have such a Lambda, you can absolutely run it locally. You can ship it to a Docker and run it as Lambda. And I did it several times, even in Java user group over files, and we can do it again, but without how it's called, the leak, I forgot, the Bearwoods, which is very good, to kill the gems and viruses, but very bad for coding. So now small apps become AWS Lambdas. No kidding. So this is my approach. We have one Maven in the entire thing, the entire Java app or a larger microservice becomes a single Lambda. If you ask me, is Lambda not powerful? You can have 10 gigs of RAM for one single Lambda and for 6 cores, which is good enough, right? So this is actually almost more than Fargate, because in Fargate you can only have 4 cores. And by the way, Lambda is also used for machine learning, so it would be good enough, to have one Java app. Fast startup with GraalVM, we never did it because stock Java is fast enough. And so what we have, no modules, no playing, we have one project with nice packaging, and it is highly productive because this is like back, to 1995. We just write simple Java code. And we use microprofile in Jakarta E, so actually no difference to all, the conferences I talked to. If you would pick, a code from a conference 15 years ago, it was still run as a Lambda. Maybe GSF won't, right? Because it's front end, but the backend, CDI, JAX-OS runs one-to-one. And in asynchronous Lambda, we don't even use microprofile in Jakarta. We just use Java SE without any external dependencies, which is also very good for security, of course, these days. So we have no external dependencies, so we don't have to upgrade anything. Okay, serverless impact. What it means to you if you start a serverless Java project, no singletons. Now it comes no connection pooling. We learned why, because if we go here, right, and every Lambda would open a connection pool with 50 connections, we would have 1,000 Lambdas, and we get 50,000 connections to database. The database will die. So what you can do at most is to open one single connection. So this is the huge difference between Lambdas and non-Lambdas environment. Okay, there's no state, and this is also, I work in a team with developers, and they forget that we have Lambdas, and they ask, from time to time, could we introduce caching? It's like, we could boil a Lambda. Oh, we forgot about this. So this is extremely transparent, and it would even work actually until you get more load, because what will happen if you talk to a single Lambda? There's one single Lambda active, so you could even use your singleton, whatever. But if you generate more load, more Lambdas which is going to be started, and then your application will become, inconsistent. Very similar to message-driven beans behavior back then. So as long as there was no traffic, you could store stuff in one message-driven bean. If there's traffic, everything gets inconsistent. No state, no caching, and everything is request scope. But if you think about this, request scope can be optimized because there's only once. So actually, what we use application scoped. Also, the cool story, all the patterns in Lambda, like eager initialization of resources, we get it out of the box because we can use application scoped in post construct, and this is initialized once. So actually, all the micro profile primitives work really well with Lambda.
So Adam, there's a question about the cloud impact from Stefan. Could you give a ballpark estimate for running costs, serverless Quarkus versus regular microservices in Kubernetes with Quarkus? Small resource allocations and GraalVM native image builds.
Yeah, what I can tell you is the Kubernetes costs €100 a month, roughly just the control plane without any worker node. So this is consistent across crowds, I would say. And if you have a Lambda, which Firefox, calculator AWS. I do it all the time. I get the questions very often. So what you can do is we can say Lambda. This is highly interactive Keynote, right? So no free tier, which is and Frankfurt. We have to go to Frankfurt. Is more expensive, and we can use ARM, which is a little bit cheaper. Let's say 2 transactions per second, the entire month. Duration, you will see, I would say 50 milliseconds is a lot for empty Lambda. If the Lambda does, calls the database, then it's the problem of the database. And I always pick 1 gig at least of RAM to get more CPU. And if we take a look at the things, it will cost you $4 a month. So we can use 25 applications for 1 Kubernetes control plane already. So this is the costs. And GraalVM, this would be 10%. So with GraalVM, it will cost not $4.50, maybe $4.30, right? And in my current, but this is what I said. This is architecture 250. Okay, if you go to 150 milliseconds, but then you have to already calling something. This was the empty overhead. So this is $11. 2 transactions per second all the time, and you can buy, in advance the compute, and it will be 20% cheaper. But this is the cost of Lambdas. I would say unbeatable, because in an enterprise project, it doesn't run 2 transactions per second the entire time, right? So it's okay. And we don't have to care. By the way, Lambda is the most secure solution because it's not containerized. They are running on Firecracker micro VMs, which are completely isolated. So they are a highly certified solution, which is also a reason why we use Lambdas in some projects, because of compliance. Okay, cool. Back to the slides. Very good question. We have to send the guy, some stickers with JCON or
of course. Barefoot, of course. Okay. You get good feedback here. Stefan, thanking you. And we have another question. Do you want to take it right now?
Yeah, sure.
Okay, we have a question from Kurt. Assume you have a microservice with its own in-memory data store in a CQRS architecture. Does this approach fit a Lambda as well? No. In memory, forget it. So you have to externalize somewhere. This would be not the right solution to Lambda. So Lambda is always stateless. So this would be, you could do this, but this is fiddling. Then I will go Fargate. Something, with, if I have something in memory, I will go Fargate or ECS or ACI on Azure or Azure Container Apps or something like this. So now it gets important. There's one.
I have to, sorry?
Or don't we have time for the question anymore?
Next question. I have 2 important concepts I would like to cover, and then the question.
Okay.
Or we kick out the next speaker and we have more time. It depends on you now.
Can't do it. So we will hold the questions for now.
I just wanted to see your reaction. So
we will hold the question and put them at the end. Put them in the chat. Very good. We will get to it in the end. Okay.
Now this is one of the most important slides. Now I tell you something which is exactly contrary to what I told you 10 years ago. If you go to the cloud, what I do, I prefer the proprietary solutions from the cloud. And this is on the slides. Why? So infrastructure as code, what it means is infrastructure as code, you create the entire infrastructure. Now the question is the table or a topic the infrastructure or not? This is really important. So if you use managed cloud native services, I show you in a second, like DynamoDB or Kinesis, you can create a table with infrastructure as code, with Java code. If you use Postgres database, you provision the Postgres database, and then you need additional script or something to create the tables. A huge difference. So what means is, this is the entire code to create, this is Java code, to create one topic which is similar to Kafka topic in the cloud. There is no such as CDK construct to create a Kafka topic. You will have to create your own resource. So what it means is, if you go to the cloud, the first question, architectural question, is about the persistence. Is it okay to be depending on the cloud provider or not? Now, what I noticed, management is afraid of being depending on the cloud. So, hey, we go to the cloud, but not really, right? So, but they already are completely dependent, because the highest coupling to the cloud you get if you are, this is the IAM, you know, this is the identity management. The entire networking is highly proprietary, and I spent most of my time in non-serverless project fiddling, you know, with routing, subnets, and network load balancers and stuff like that, which is highly depending on the cloud. So I really don't care about the database anymore. So this is maybe the difference. But if you're on premise, the standardization is completely different, you know, because the entire networking is not our job to solve it. So what we focus on is abstracting from products. And if you're in the cloud, you are responsible for everything. So I would say it is, you know, a streamlined infrastructure is incredibly important. So this is how this Java code creates in about 2-3 seconds a topic in the cloud. This Java code will create a Dynamo table with, you know, security, everything in the cloud. So if we use RDS databases, for instance, RDS is relational database service, Postgres or MySQL, we get an empty database, and then we need a script to provision the tables. A huge difference in release management, okay? So cloud native persistence. So now if we take a look what's there, I just picked, you know, some services. S3, it's a simple storage service, should be actually serverless storage service, because really serverless and highly compliant. And I have to say, I like it a lot. So in clouds setups, I prefer S3. I start with S3, which is also highly unusual because it looks for Java developers as a table, hash map. The cool story is, what I forgot to mention is, the managed cloud native services, or why this is working. This is working because in all the clouds, if the service is proprietary cloud service, usually it can be accessed via HTTP or, you know, the cloud protocol. If the service is an open source service like Elasticsearch, Postgres, the setup works via HTTP, but you still have to use the binary protocols to talk to the service. And now maybe you see where I'm going with it. So S3 is HTTP. It means we don't need pooling. We have a Lambda, and they just call, you know, to S3. No one cares about pooling. DynamoDB, the same. Setup, CDK, no pooling. RDS, Postgres, we have JDBC connection. And the JDBC connection, we need to maintain to, you know, create the tables and also to access the database. And there is a technology which is really interesting. And this technology is called RDS proxy on AWS. What RDS proxy is doing, it is like a shared connection pool. It sits between Lambdas and the databases, and it cares about security and is responsible for multiplexing the connections. And I don't know what they remember, at JDBC level 4 driver, I forgot to look it up actually. I think the level 4 driver was a middleware driver, which is RDS proxy could be considered something like this. Now, there is Aurora serverless proprietary AWS extension to Postgres. What's interesting is the V1 version from Postgres comes with data API. So what they did on AWS, you can access the Postgres database via HTTP. And I was already in projects about to think about this because, again, if we use it, the proprietary HTTP API, we don't have the problem with the connection pooling, and there is no binary. We just use the same channel for everything. The new version V2, I don't think whether it gets the data API, but is not set up yet. So, and there's Kinesis. You already saw the code. What Kinesis is a serverless, let's say, how to call it, is very similar to Kafka. It's like event sourcing solutions or persistent topics. And MSK is managed Kafka There is a serverless option, non-serverless option. You can just use it. The problem is, of course, you will have to create and maintain the brokers and the topics by yourself. So there is no CDK API for it. So this is what you should know. If you think about persistence, you should also think of how to manage the stuff. And what I would like to do is, to manage everything from Java. So now relations or redundancies. So what interesting is, if I work, with Java developers who like JPA, they always still have the relational thinking and have to, would like to have relations in order, to optimize the storage. I would say no one cares about the storage because really cheap, and CPU is still expensive in the cloud. So what I will optimize for is not for storage rather than for CPU. So what we start with Java, we just start, with NoSQL databases, which can be S3. So we have a huge JSON blob and store it to S3 and read it from S3 and don't think about the relation. So not, we misuse S3 like a file system maybe, and it works surprisingly well with some problems, of course, N+1 problem. So if I would like to go, to a hash map and say, I'm searching for everything, so I have to go through all the buckets, and in S3, I will have to go through all the keys. What you can do, you can use, it's called S3 select, or you can use Athena, but you have to do something about this. It doesn't work out of the box. And relational database is a different problem. Someone asked about the costs. Even a mid-range Postgres database will cost you 600, 700 euros a month. This is what I saw. So we did the calculation several times. And you have to care about the subnets, the routing, public, private subnets. You have to care about backups, snapshots, and maintenance windows, which is not fun. If you use DynamoDB or any other database, such things do not exist. Okay, formats. So we have JSON, CSV, Org, Avro, Apache, Parquet. This is what you can store in NoSQL databases. And I say, okay, if I just have a blob, instead of using JSON, I could use, for instance, MicroStream. So we played with MicroStream on different Keynote. So there's the recording. So so maybe it will be in the show notes or in the I will put it into the slides. So the idea is JSON is great, but comes with limitations. Try to store date, for instance, in JSON. So you have to do something about this. Or we pick a Java serialization, but the problem is Java serialization is not that secure. And Markus Kett, this was I think the speaker before me, I saw him briefly. He claims MicroStream is secure. So this is if you buy support for MicroStream. So then it is you can count on it. But what you can do, you can use MicroStream, for instance. This is the code. I just pick it up from you have one single dependency, and you can store, the entire Java blob in S3 or whenever you want, right? So the question is, from the architecture, are you storing the data to further processing? Would you like, for instance, with that, you get a very similar architecture, what I told you at the beginning, domain-driven design, because MicroStream, will load the entire object graph to memory. This is the options you have. And now, Richard, I'm open for further questions, because this was the last slide. And if you're interested, you can join the workshops or ask me questions.
Okay, we can do 2 more minutes because we're already at the end of the time slot. And I will see if we have any questions left in the...
There was one question, which I ignored.
In the chat, let's see. This was a comment on the CQRS question. The question was, assume you have a microservice with its own in-memory data store and a CQRS architecture. Does this approach fit a Lambda as well? And then there was another comment that said the in-memory data store is populated through a consumed event stream each time the query service is started.
Yeah, I mean, it really depends, because if the Lambda is used, the entire time, and the cache is just an optimization, it could work, because the Lambda is called, by data stream over and over again. But if a new Lambda is started, it will be empty. So, and then you have to pre-populate, the data from somewhere. So it could work. I wouldn't start with it. So what I try to do is to start, without any cache, and see what happens and measure the performance. Usually, is this good enough? This is what I would suggest.
Okay, then one more question about the slides. Adam, you will give us the slides. We will upload them in chat in the session planner. So just go to the session planner and in a few hours, and you can download it where you joined this session. And then the last question, then we will close this keynote. Did you already did the same thing with Microsoft Azure?
Yes, and in Microsoft Azure, there is a different strategy. Microsoft Azure, maybe GraalVM is more interesting because in Microsoft Azure, you get paid per memory. So in GraalVM could be cheaper. And on AWS, you are buying CPU with memory. So you have plenty of RAM usually. So Azure is very similar story. And in Azure, the only difference is there are several plans. And it really depends, if you would like to have private networking, you need the premium plan and so forth. So, but it works almost identically. And the only difference is there are lots of questions. I wanted to show you a live deployment. On AWS, there is a Quarkus extension, which creates, the Lambda communication layer. And on Azure, there is an official Azure Maven plugin, which deploys the Quarkus to Azure functions. Yeah.
Okay, great. Then from me and the whole JCON team, thank you, Adam, for joining us for this keynote. For everyone attending here, stay tuned. Now, after the sessions, we have the 5 tracks open again. See what sessions you like. There are a lot of great topics, and at 1800 hours back in European time, we will have a keynote with Josh Long for the Spring folks. So stay tuned for that. Thank you, Adam, and have a good time.